Hello, ladies and gentlemen. Welcome back to math. Today we're going to wrap up everything that has to do with polar, okay, polar expressions, polar equations, okay. Today we're going to graph those equations, meaning the objective for today is to graph our polar equations, okay. Our parent function is written as the following. We have r equals function theta. Okay? If you guys remember, r is our radius. Okay? Theta is our angle. Okay? In order to graph polar equations, okay, we have to set up a chart. Your theta is your input. Your R is your output. Okay? Meaning, we're going to plug in numbers or radians or degrees, okay, into our theta to get our radius. Our equation looks something like this. Let's use purple. Okay? Well, first things first, before we get into that equation, I want to go over something really quick. Okay? We usually have two types. If you guys remember on previous concepts, whenever dealing with the unit circle, we have cosine and we have sine. Okay, or vice versa, sine and cosine, depending which you want to go first. As x is sine, and x is cosine, and y is sine. Okay. When you have an equation, when it comes to circles, because the unit circle is a circle, we usually see as a, okay, as our radius. Okay, meaning that the A tells you from the origin or wherever your point is at, okay? It tells you how many to move to each side, okay? How many to the left, to the right, up and down, okay? All with your A. When it comes to sine and cosine, okay, it becomes your diameter. Okay, A is the distance from one end to the other. Okay, this is only with cosine and sine. Okay, this is with circle. So we're kind of going from circle to sine and cosine. Okay, so in our minds we have to say, okay, now A, it's our whole diameter. Okay, so the equation goes as the following. You might see it, again, one of two ways, because you have sine and cosine. You might see it as R equals A sine of theta, or R equals A cosine of theta. Okay, again, this time R is our diameter. Where sine and cosine, I will say this, okay? For sine, okay? Since we're only dealing with parent graph, okay? That's all we're going to deal with. We're not going to get into that fancy stuff where you shift it, okay? We're only going to get into the very basics of it. Sine theta, okay, means that your circle is going to be on the y-axis, okay? Let's use another color. The y-axis. Meaning your circle, okay, or petal, okay? If we would have got a little more fancy, there were going to be petals, but since we're dealing with just the basics of it, it's just circle. It's going to go from center, from the origin, open either up, or if it's a negative a, then it's going to open down. Okay? For cosine, we have x-axis, where we're going to go from our origin. Okay? Let's go with purple. We're going to go from the origin. It's going to open either right, or it's either going to open left. Okay? Notice why I say petals, because once we get into more complicated problems, you're going to start seeing a little more of it. Sorry about that. All right, make sure you have the very basics of it on your notes. Remember, sine is y-axis, cosine is x-axis. All right, let's erase it here. All right, now that we have all our basic information, we can actually start with the problem for today, which is we have r equals 4 sine, oh, it's a little wet there still. Sine of theta, okay? Now, what we have to do is, we have to create some points, okay? I will say this to you. Always use the ones that are on the unit circle, okay? So we're gonna do this. When I say we're going to do a chart, whenever you do a graphing chart for plotting points, you have x and y, okay? Here we're not going to do x and y. We're not going to do sine and cosine. What we're going to do is we're going to say r and theta, okay? So we have, I'm going to start with theta, then I'm going to do r. This way, because r is our output, okay? Alright guys, notice that I already have them all up here, okay? I had to pause the video so you guys wouldn't be waiting for me to write them all down. They might not be exactly in order. I try to keep all the 6's together, okay? All the 4's together, the 3's, all the 2's, okay? But I have the whole unit circle here, up in the board, okay? We have all our parts, all our radians. Okay, now that we have our radians, okay? On each of those radians, since we're dealing with sine, we have to look for sine on those radians and then multiply it by 4. Okay? So, on 0, okay, on the unit circle, 0 on sine. Remember, we have our first point, our x-axis, and our y, which is cosine and sine, okay? We have 1, 0, 4, 0, okay? Remember, we're only looking for sine, so sine is 0. So 0 times 4 is 0, okay? Now we're going to look at pi over 6, okay? Pi over 6, our sine is, if you guys remember, on pi over 6, it is 1/2, if I'm not mistaken, which it is. So we have pi over 6, which is 1/2. 1/2 times 4, so we have 1/2 times 4 over 1, which is 4 over 2, which is 2. Okay? Then we have pi over 4, which in pi over 4 is radical of 2 over 2. So radical of 2 over 2. times 4 over 1 equals 4 radical of 2 over 2, which 2 can go into 4 2 times. So technically becomes 2 radical of 2. Okay. Then we go to radical of, or pi over 3, which sine on pi over 3 is radical of 3 over 2. So you have radical of 3 over 2 times 4 over 1, which is 4 radical of 3 over 2, which technically again becomes 2 radical of 3. Then we have pi over 2, which is 90 degrees. Okay, this time is the opposite. We have a 1. Okay, so 1 times 4 is just 4. Okay, then we have, should we start off from the bottom? You guys start from the top. It really doesn't matter, because once you graph it, it's all going to make sense. So since I try to keep the pi or the 6's together, I put pi up here for our first one. So pi, again, this time we're dealing with the opposite. Instead of a 0, well, technically still 0, okay, because it doesn't move on the y-axis. So again, 0 times 4 is 0. Okay. 5 pi over 6. We have, this time it's still positive. So 5 pi over 6, we have 1/2. So again, 1/2 times 4 over 1 equals 4 over 2, which is 2. So notice how the pattern keeps repeating. We have 0, 0, 2, 2, 3 pi over 4. Again, 3 pi over 4 is radical of 2 over 2. Okay, so radical of 2 over 2, technically we already have it. So technically our answer is 2 radical of 2. For 3 pi, we technically, again, we already have it, 2 radical of 3. Okay. 7 pi over 6. Again, 7 pi over 6. This time, 7 pi over 6, we have a negative 1/2. Okay, the only thing that's going to change now, it's that sign. Okay, because it's technically the same number, the only difference is the sign. So this time, since the 6 was 2, this times the 7 over 6 is negative 2. Okay, since we're dealing with the 6's, on 11 over 6, we still have a negative 2. So technically, it's the same thing. Okay, so these two quadrants, which is quadrant 3 and quadrant 4, since they're dealing with negative numbers on sign, they're going to have the same answers. Okay, so this time on the 4, we have 2 over radical of 2. So now we're going to have negative 2 radical of 2, negative 2 radical of 2. For the 3, we have 2 radical of 3. Now we have negative 2 radical of 3, negative 2 radical of 3. And then finally, well, for the half here, this time, again, we have a negative for 3 pi over 2, which is 0, negative 1. Since we're dealing with a negative, again, since we had 0, 0, this time we're dealing with a 1. So negative 1 times 4, okay, is negative 4. Because you had a 4 over here, you have negative over here, okay? The same with 2 pi. Since you're dealing with 0, technically it's just at 2 pi, we have a 0, which is 0. Okay? So now that we have all our answers, we can actually graph this. Okay? Alright, so we have 0, 0. That's our first one. Okay, we're going to turn the camera here a little. Let's use the little ones. Let's make our graph. I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. All right, so we have 6 in all directions, okay? Now that we have our graph and we have our solved problems, okay? The first one, we start off at 0, okay, for 0 theta. So we're going to make a point at 0, okay, at the origin, okay? Now, for pi over 6, okay, we're going to go to 2. So pi over 6 is roughly, if we want to do those 3 little lines in there, okay, which is we have our 45, we have our 30, and then we have our 45, or I mean our 60, and then our 90, okay? So this first line at 30, we said we were going to go 2. So we go to 2, and we make our dot, okay? Now on the next one, which is pi over 6, or pi over 4, I mean, which is 45, we're going to go 2 radical of 2, which 2 radical of 2 is about, let's see here, let's use a calculator to find that out. Okay, where's my radicals? All right, 2 radical of 2 is 2.8. Okay, so about 3. So a little less before 3. So on 45, okay, we're going to go about 3. We're going to put a little dot there. Our next one is 60 degrees, which is pi over 3, which we had 2 radical of 3, which 2 radical of 3 is around 3.5. So at 60, we're going to go about 3.5. Okay. And then at 90, we're going to go up to 4. Okay. 1, 2, 3, 4. Okay. Now, we're going to do the same thing for the other ones. We have pi at 0. Okay. Pi at 0. Then we have 5, 6, which again, if we want to do our little lines, okay, we have 2, so we go to 2 here, then we go about 3 on the next one, and then about 3.5. And then we go to 2. So our graph is going to look something like this. We go from the origin to our first one, to our second one, to our third one, to our fourth one, and back to the original. Okay, well technically we go from here. We go here, then we go from here, here, okay? All right, so now we do our next one, which is, again, distant or negatives. So technically, we go on the bottom. Okay, so we go our little line here. We make our lines. All right, so we have again 2, a little more, and then our 4. And then we do the same, okay? And then obviously I'm not going to show this one here, but it's going to look the same as well, okay? All right. I know it took a lot of time, okay? I'm actually going to do this. I just want to show you how it looks when it's graphed. I'm not going to have you guys really graph it, okay? Because it takes a little bit of time finding all the different points. So I want you guys just to find all the points to the equation I'm going to give you, okay? Make sure you have all 4 charts, one for each quadrant. All right, guys, so here's your assignment for today. All right, your first one is R equals 3 sine of theta, I guess of R, 2 cosine of theta, okay? I picked pretty simple ones, okay? I choose one for sine, one for cosine, okay? All right, make sure you submit your answers as soon as you're done watching the video, and I'll be here waiting for your email.